Hey there, Math Rockstars. This video will talk about the rule of 4. The rule of 4 refers to representing functions in 4 different but very connected ways. It looks at the verbal description of a function, the model or the equation of a function, the graph of a function, and the data that is generated by a function. And usually you see that data as a table of values. We're going to be referring back to the rule of 4 in every single module this summer. And over the course of the summer, I'm hoping that you're going to get very good at going back and forth between all parts of the rule of 4. Once you get into pre-calculus and then definitely into calculus, you're going to be needing to go back pretty fluidly, back and forth between verbal descriptions and coming up with an equation, or looking at a graph and generating the equation in a table of values, or looking at some data and saying, you know what, I think given the context, given the verbal description, this would be the best model, this would be the best type of equation to describe this particular function. So when we look at the verbal part of the rule of 4, most times people will think about the context in which the function is being used, and you might think of it as the word problem part of a math question. Included in the verbal part of the rule of 4 are things like the domain, the range, intercepts, so ways that we use to verbally describe a function. Usually it's a function's graph. And we're going to be spending quite a bit of time on each of these individually, but for this video, we'll just define them very quickly. Domain and range are verbal parts of the rule of 4 that you're already quite familiar with. The domain is just the x value, and more particularly, it's the independent value in a function. And of course, the range is the y, or the dependent value in a function. Dependent value of a function. Mins and maxes, those are just highs and lows, and we'll get pretty specific about finding minimum and maximum values this summer for some functions. When you get into pre-calculus and then definitely calculus, you'll be discussing things called relative minimums and relative maximums a lot. But for today, just remember that mins are the low values and maxes are the high values. So low and high values. Intercepts are the places where the graph of a function crosses the x or the y axis. So these are points where the graph of a function crosses. And instead of saying x and y, I'm going to use horizontal and vertical. So horizontal and vertical axes. And the reason that I'm saying horizontal and vertical rather than x and y is because we don't always use x and y as our variables. You're going to see s's and t's and g's and h's and all kinds of variables over your course as mathematicians. So you probably are better off thinking instead of x's and y's, thinking independent and dependent and horizontal and vertical. It's not wrong to call them an x-axis and a y-axis, and you'll hear me saying that as well. But more generally, and perhaps more accurately, to call those axes the horizontal and vertical axes, I think would be a good idea. Last term on our list is end behavior, and end behavior is what happens to the range of a function as the domain gets either really, really big or really, really small. I'll go off of this page for just a second So in other words, if I have some sort of, here I have a x and y axes here, and I'm looking at a function, here's my function, as I head off in the positive direction, so I'm heading off to positive infinity, and my numbers are getting really, 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 really big, like way out here at like, I don't know, 1,000,000. I want to be able to describe what is happening to my function. How tall or how low is it getting? So in this case, it looks like my function is also getting really big. Look, it's heading off in this direction. So the height of my function, or my range, when x is going to positive infinity is also positive infinity, right? It's increasing. It's also getting really, really huge. Doesn't have to be the case. I could have a different function. Maybe I have a function that does this. It starts off kind of big, but as my domain gets larger, as my x's get bigger and bigger, my function gets closer and closer and closer to the x-axis. So in this case, although my x's, my independent values are getting big, my y's, or my dependent value, my ranges, are getting very small. So they are getting small. They are dropping. And being able to describe that is what we refer to as end behavior. What's happening at the ends of the graph. It's not just limited to positive infinity. We can also think about what's happening if I was backing up. So if I'm heading backwards, and from reading from right to left, and I'm heading back towards negative infinity, way the heck out at the left-hand side of my graph, what's happening to my function then? Well, in this case, my function's y values, the dependent values, are getting pretty huge, right? They're climbing and climbing and climbing as my x values are getting very, very small. So I can talk about end behavior in both directions, both towards positive and towards negative infinity. And in our other video, I will spend a bit more time explaining the notation of that. But for right now, we'll just think of end behavior as what happens to the range of a function as the domain gets really, really big or really, really small. So end behavior is what happens to the range of a function as the domain grows very large or very small. So that's end behavior. And this verbal list of descriptions goes on and on and on, but that's sort of some of the general and most common ones. The second part of the rule of 4 is a model or an equation. We'll use function notation here rather than the x or the y's. F of x equals x cubed plus 2. So that would be a cubic equation. And here's another one, g of t equals t squared. So these are all just models or equations that could be used to describe a function. Here's a line, y equals 2x minus 1. So these are all things you're probably the most familiar with using, the models or the equations. The third part of the rule of 4 is the graph. If I were going to graph that cubic, it would look something like this. It starts pretty negative and goes through the origin and then heads up in a positive direction. So that's a graph of f of x equals x cubed. And of course the line, you know what that looks like. So these are all the graphs of a function or an equation. And then the last, of course, would be a table of values, where if this is my x and my f of x, my independent value is x and my dependent value is f of x. And I'll stick with that cubic equation for right now. If x were 0, well, then f of x would also be 0. If f if x were 1, then f of x would be 1. If x were 2, f of x would be 2 times 2 times 2, right? 2 cubed, that would be 8, and so on. So I can generate a table of values if I have a graph, if I have a model, sometimes if I have a context. And I could also look at that table of values and say, well, from 0 to 1, my function is going up by 1. And then from 1 to 2, my function, is that going up by 1 again? If it was going up by 1 again, maybe it's linear. No, not anymore. It's going up by 7 now. So I know it's not linear. I need to be looking for a different model to describe that data. So that's what the rule of 4 is. Being able to describe a function in words, using a model or an equation, using a graph, and using a table of values. And your job over the course of this course is to learn how to go back and forth between those 4 parts pretty easily.